the outline. I will take a few minutes to explain first what I mean by dynamic software updates and why it's still challenging today. Then I will briefly present the approach at more conceptual level, and then a few words on the implementation. All the rest of the details, so you can look at the paper, it will be kind of hidden. So first, why is dynamic software update challenging? For the sake of this discussion, let's consider that you really want to build a system that is in production and that is live, that has lots of a load that is constant. Let's say you have web server and there's always customer on the website and you always have requests. So that's the setting. And you want to update the system. So it's slightly different from updating a small document or developing. You have always a load in the system. And we can consider a web system like here or something that has a page, like a web system. And let's imagine that on the left you have the initial version of the code, and on the right the new version, and you have a field, HTML, that is split in two fields, title and body. So that's the setting. And how do you install that on the system live? And you want the stuff not to produce wrong results and so on. So that's about safety. And because if you cannot afford to shut down the system or wait until there is no customer on the website, that means that probably you cannot afford to have failure or something that is completely wrong. So we have a bunch of questions related to this problem. So for example, how can we migrate the state? The evolution that I just showed with the page. If we do the change in Smalltalk, we just create a new version of the class. Then we will have two fields, and the new field will be initialized to nil or something else. And that's not what we want. We want to have the same content. Let's say the HTML is just split in body and header. That's a big fake. You could imagine in another setting. We want the same data to be migrated. So that's one problem. How can we migrate the state of the application? And another problem is, so we have a system that is live, we have lots of requests that are always coming. And what happens when we install the update and we migrate the instance? We might still have old code running somewhere in an old thread that is not completely over. And it might want to access the HTML field or the HTML instance variable, and the new request might want to access the new instance variable. And how can we ensure that does not happen, that we don't end up with these kind of issues? And third, if we do the installation at the point in time, install the new code, how can we ensure that we won't mix old code and new code in the same execution thread? That the requests are consistently served. So those questions about safety of the update are not so easy to address. But there has been lots of research on that. I mean, those problems are not new. So here's a brief summary of existing works, but basically that's a trade-off. That's a trade-off between three, let's say, dimensions. One is safety. So the fact that you don't want this kind of error that I just described to happen. One is the time. You want the install to happen as quick as possible and as fast as possible also. For instance, you need to migrate the state, you don't want that it takes long. And you want the system to be practical. That means that as a developer, you don't want to have a complicated machinery, or you don't want to have to think about invariants in place. Or you want something that is easy to use. And here are a few of the work that exists in this solution space. And on the top, we have something like Smalltalk or some other system that has something like this that all try to do the same mechanism. So they are very practical, very timely. We just install that, and then to change our install, to migrate the instance. But it does not cover those safety conditions. For example, the new instance would be, new field would be initialized to nil. And you don't have a way to really address that properly. So in practice, you need to have scripts to fix those objects, to adapt them correctly. On this side of the triangle, we have other systems that use so-called update point, and the idea is that you delay the update until it's safe to install and migrate the state. For web systems, that would be, for example, when there is no customer, or when all requests have been served, you update, and then you start serving requests again. But then that goes against the timeliness of the update. You need to wait until this condition occurs. And probably, if you cannot afford to shut the system down, you cannot afford to wait, or to wait until all requests have been served, all this kind of stuff. And there is certain kind of system that are safe and timely, but then you need to have some restrictions, like you cannot add new fields. In the case of hot swap to Java hot swap. And so that leads to solution to it. And active context, that's the name of the approach that I propose, tries to be a good balance. I do not dare to say that it's the ideal one, but that's a good balance between something that is practical, timely, and safe. So that was the first point in the outline to understand the setting. And the approach is kind of simple idea. The idea that we want this safety to be here, and what is missing is something that we call context. That is first one that we can use, and in which context we run code so that it's always version consistent. So basically, when we pass a block and we execute this block within the context, we are sure that we will not face those kind of issues that we have with fields and updates and code. So it's version consistent. And if you want to do a change, you create a new context. Then the question is, how can we make some context coexist in the same object space? Because we still want to be able to share objects between the contexts. If objects are local to a context, that's easy. You can have a page that would be that would have only one HTML field and a page with those two fields. As long as one is only used in one context and the other in the other context, that's fine. The problem is the model, like the page in this example, is probably shared between several requests. You might have all requests running the old version and requests running the new version. And then again, the idea is kind of simple, that we want the machinery of this approach to handle the synchronization between the representation of the object. So an object can have several representations that would match the corresponding context so that we don't end up with these safety issues. And to synchronize the representation, we provide transformation, bidirectional transformation. And this simple setting supports the state transfer, the migration of the object, because in the transformation we can specify how we want to migrate the model, the object. It's safe from the point of view of concurrency. Plus, the context is something first class, so it fits well in the reflective architecture. You can instantiate a new context and start using it, and let the system evolve. I won't go into detail, but that would be the body of the transformation. For that, you can read in the paper if you want. The problem, well, not the problem. With this approach, we need to distinguish between two meta levels. One is the application, and one is the machinery that supports this model, which will synchronize the representation of the object with its transformation. And this synchronization happens conceptually at another meta level, into which you don't have any context. So the transformation needs to be written in this way, but basically we see that we have the ancestor, because contexts are changed. We have the old context and the new context, and you can manipulate the object and adapt them manually. So here, I would read the HTML for an object, store that in the variable HTML, then I can split it with the regex, and I can assign the body and the header in this new representation of the object. For the application, you just manipulate the object as usual. So that's basically, from the conceptual point of view, that's how it works. And so that's a short talk. So here I will give a few words on the implementation and a few design decisions on how we can implement this model. Basically, there are two strategies to build this model. One would be to eagerly synchronize the representation of the objects, and one would be to lazily synchronize the representation of the objects. For instance, if from one context I change the HTML field, given the example that I have, if I'm in the eager strategy, that means that the representation is header and body is computed immediately in the other context. That would be the eager. In the lazy strategy, that means that you just change the HTML, and only if somebody reads the header and body in the other context, then that will be transformed. And there is a few other considerations regarding those two strategies that are possible. Its initiation is when you create first the context. If you're in the eager strategy, you need to create the representation of all the existing objects, while in the lazy strategy, you do nothing. Then, from the point of view of the conferencing and you read and write, if you're in the eager strategy, synchronize immediately, synchronize and write. In the other case, you synchronize when you read the object in 30. And then there is also a few implications for the garbage collection. If you're in the eager strategy, the word is always consistent. When in the lazy strategy, you might face some issue that an object, an old representation of an object is not used in the old context, but it has not been yet migrated, so you need before this migration. And a few differences. That's not really free here. That's what is implemented right now, and that is what is in the paper. So we have basic implementation working, but again basic. That is eager, that migrates object when you create the context, and asynchronous on the right. Few more words, because we are in small talk in my first classes. The question is, we have objects that are contextual, they can have some representation, and the same should hold for classes. And that's actually nice, because that means that we can evolve the classes, and that we don't need two versions of the class. That will be one object, one class that has two versions, but it's slightly different. Again, right now that is not implemented, but that's the future plan. And that supports the evolution of class hierarchy better. Well, here we see in the code that given that we don't really have that, we have the page and the page 2 that are different classes, and the idea is that will be the same classes but two different versions. So that's for the future steps. So for the details, you can have a look at the paper. So as a conclusion, that's a simple model, just one new abstraction, that is the concept, it's a first-class context, that provides version consistency when you execute the block code, and that enables safe dynamic software updates at the expense of some machinery that need to synchronize the representation of objects, and now the question is how to make that fast. We have a working implementation that is using eager transformation that has some overhead that is significant in a way. And we plan in the future to enable this lazy transformation that should provide better performance and have also some nice characteristics, and also to work on the classes. That's it.
Okay. Thank you. Moving on to questions.
Yeah.
The transformations are completely written by the developer. This means that each time you change a single class, you need to write transformation. What is did you make some evaluation of the overhead for writing these transformations?
So at the moment they must be written manually, and that's of course a good question. What's the overhead to write it? But we must imagine that it's not for developing the system, it's rather for maintaining a live system. So you have a version, a new version, you know that they work. If you know the data, then you need to write those transformations indeed with the classes that are changed in a way to migrate the object. And that's true that for the moment they will be manually written. But that's somehow a Portugal question. There are other works, I could refer to other works that where they have automated that with IDE to support that kind of knows about the change and can generate part of the transformation. So we could use those existing approach to lower the manual work. That's clear. That would be nice if you complete two set, but that's a somehow side question. But that's a pretty good question.
I have a question. All your examples are web-oriented with HTML pages. Can you imagine to use such a system in, let's say, financial systems or like our legacy system in our stock, with a high risk of failure in case of evolution? Not mentioning HTML server,
Well,
system.
pretty much all those kind of systems still serves requests. So any system that serves requests could be built like this. Yeah, I don't know what kind of system we have in mind, but even if you take some financial transaction processing systems, I guess they probably serve requests and that would work because we can update that per request per session. You could imagine actually I have a small demo. You could imagine we have that for 10 minutes where the session is longer than the request and one guy when you connect with Tennis, you always see a consistent version of your connection.
Another example to imagine is deliver a version of a tool, let's say, any tool to a client and perform some evolution offline, work and mix new versions of objects. You see what I mean? I have a system with objects, okay, and you have some bug you want to fix, and you generate a new version of your classes and so on, and you inject it with a transparent version to the client. You mix it and inject. It's a running system. New objects with no restriction, except working the countries who are without working.
So the problem of updating the client is also another question. In the case of that work on the server, if you want to update the client, you basically need to ship the code to the client. That would start using the right version of the code to the client side and connect using the right context. Interesting. I don't know to try it.
We'll get it offline. Right. Another question? Okay, so thank you again.